Hardness test. Hardness test measure material's resistance to indentation, scratching or wear. It is used to check strength, durability and quality of a metal. Types of hardness test. There are 4 types in hardness test, which is Brinell hardness test, Vickers hardness test, Rockwell hardness test and Mayer hardness test. Today we are going to see about 2 important hardness tests, which is Brinell and Vickers. First one is Brinell hardness test. It was introduced by J. A. Brinell in the year 1900, and the intentar used in the Brinell hardness test is hardened steel or tungsten carbide ball, and the diameter of a ball is 10 mm, and the load range is from 500 to 3000 kg force. The load range is given depending on the hardness of the material, and the load is applied for 30 seconds. Let us consider this as metal. This is the indentar. This is the impression created by the indentar in the metal, and this is capital D, which is diameter of the indentar, and this one is small d, which is diameter of the indentation. Brinell hardness number. The formula used to calculate Brinell hardness number is P by surface area of indentation, which is equal to 2P by pi into capital D minus square root of d square minus small d square. P is the applied load and d is the diameter of the indentator, and small d is the diameter of indentation, which is the impression created by the indentation. T is the depth of indentation. And also the unit for Brinell hardness number is kgf per millimeter square, which is approximately equal to 9.8 MPa. And the advantages of Brinell hardness test. Large indentation averages out local heterogeneities or of microstructure. Heterogeneities means non-uniformities or irregularities. It averages out irregularities of a microstructure. Brinell hardness test can be used to cover a wide range of hardness, and it is less influenced by surface scratches and also the roughness. It is suitable for casting and forgings, which means shaping of metals. And the disadvantages. It is not suitable for smaller specimens. It is only suitable for bulk materials, and it is not suitable for thin sections. It is also not suitable for critically stressed parts. It may cause failure. This indentar leaves very large indentation mark in the metal. So these are the disadvantages of Brinell hardness test. And the next one is Brinell test with non-standard load or ball diameter. Let us consider small d is equal to capital D sin pi. The alternative expression for this is P divided by pi by 2 into capital D square 1 minus cos pi. Here capital D square is the diameter of indentar, The angle, included angle must remain constant and the load and diameter may vary as this. P1 by D1 square is equal to P2 by D2 square is equal to P3 by D3 square. Here P is the applied load and D is the diameter of indentar. And the next one is Vickers Hardness test. Vickers Hardness test uses square base diamond pyramid indentar, which looks like this, and it is also suitable for both soft and hard materials. The next one is principle. The indentar is pressed into the material and the diagonal length of the indentation is measured. Let us consider this is metal, this is the indentar, and the angle is 136 degree, and this is small d, which is diameter of indentar. This is the impression created by the indentar. And the formula for Vickers Hardness number is HV is equal to 2p sin theta by 2 divided by L square. Here P is the applied load, L is the average diagonal length, and theta is 136 degree, which I mentioned in the previous slide. And the units for Vickers Hardness number is VHN, HV or DPH. And the conditions for Vickers Hardness test is the load range must be 1 to 120 kg force, and the load is applied for 10 to 15 seconds on the metal, and the hardness range is from 5 to 1500. In Vickers Hardness, the same scale is used for all metals. The impressions made by Vickers Hardness. The impressions made by Vickers Hardness is of three types: perfect square indentation, pincushion indentation, and barrel shaped indentation. The first one is perfect square indentation, which is made with perfect diamond pyramid indentar. It is a perfect square. And then the next one is pincushion indentation. It results in sinking of metal around the flat faces like this. And the third one is barrel shaped indentation, which is found in coal worked metals, and it results in ridging or piling of metal around the faces of indentar like this. These are the impressions made by Vickers Hardness. And the next one is advantages. It is suitable for thin specimens and can test very hard metals, small indentation and wide range hardness. It is highly accurate and used in research work. And the disadvantages are it requires good surface preparation. It is a slower process. It is not widely used for routine checks, and the equipment for Vickers Hardness is the cost is higher. And the comparison for Brinell and Vickers is the Brinell uses steel or carbide board as indentar, and Vickers the diamond pyramid is the indentar, and the indentation for Brinell is large and for Vickers is small. The Brinell is only used for bulk materials, whereas Vickers is used for thin and hard materials. This is all about both the Brinell and Vickers Hardness test. Thank you.